Hello people, welcome back to the channel. My name is Darshush and I'm a BTech Computer Science and Engineering graduate and I'm currently working as a developer in a tech company. So yeah, let's get started with today's video. I think I've shared my screen. So yeah, today's video, as you've seen in the title, it is about SQL. The original plan was to start with data engineering, but then I saw that SQL is a prerequisite for this, so I thought maybe why not cover SQL first. So yeah, here we are. So this is SQL roadmap series and this is the episode 1 for that, and in this video we'll be basically discussing about relational databases, SQL, NoSQL, and a little bit around them, what is data and all that. I'll show you what we are covering today. It should be here. Okay, so these are the topics which we are covering today. What is relational databases, RDBMS benefits and limitations, SQL and NoSQL databases. So I'll tick these off real quick. Next video would be around these topics, and we'll do some practical applications as well. So yeah, stay tuned for that. Then we'll have data definition language, which is DDL, and this would be the content of a video. These all topics, these ones. So yeah, then these three would be one video, these three would be one video, these would be one video, and the last three would also be a video. So that's my plan for now. I'm also making notes for these. For now I've written something, and I'll be sharing the link in the description, so no need to worry for that. So yeah, let's get started with SQL. And you must have noticed that every app which we use today, every app, it may be Instagram, it's Netflix, it's Amazon, it's UPI apps, it's even your college portal. All of them are basically powered by the databases, and without databases modern software literally cannot exist, I would say. But here's the interesting part: most beginners start learning SQL without actually understanding what databases are, why relational databases exist, and why companies sometimes choose NoSQL databases instead. So in this video we'll be understanding all of these from scratch. So let's get started with the first thing we'll be learning today, which is what is a database. Very obvious question. I'll just write it down here. What is database? But before learning about what is a database, we need to understand a really important part of a database, which is data. So what is data, you may ask now? So data is raw and unorganized form of information. I hope this definition is really clear. I'll just type it out real quick. Okay, done typing real quick. And now we discuss the main part of this topic, which is the database. So from the definition of the data, what do we infer? What do we understand about a database? So a database, so what data is? It's unorganized, right? So arranging them in a proper format, in a proper way, it's like a collection of data. That's what we mean when I refer to database. So database is just an organized collection of data. I hope that definition is again very clear. I'll type it out again. Now that we are clear on the definitions, let's move to what we store in databases, which is data. If we take an example of any of the social media apps, it may be Twitter, which is now X. We can take the example of Facebook, we can take the example of Instagram, and so on, whatever exists on the internet. So what do they store basically? They store usernames, they store passwords, they store emails, they store your data in short. Like it can be any data, like what story you put there, what Instagram post you made on a specific day. Anything can be considered as data, and it can be stored in the databases. I hope that's really clear. Now imagine you storing millions of user, millions of posts, millions of stories generated on a single specific day in normal text files. That would be really chaotic, right? So it's possible, no doubts about that. It's really possible, but it's not the most efficient method of storing our data, and that's when databases come into use. I hope I'm really clear with this, and let's move on to the next section of this video, which is why normal files basically fail in a mass scenario, like storing data for Instagram or Facebook or Netflix, if you consider that as well. So imagine Instagram storing everything inside random files. Problems would be almost everywhere. The first problem which we'll be noticing is duplication of data. The same information gets repeated again and again, which is not something which we want to have in a fully working environment. The second I would say problem would be searching becomes very slow. Imagine a manual file of pages, and you have to search for a specific word in that file. So that's a really chaotic thing to have, which is not anyone would prefer in their program or in their website or on their platform. The third problem I would say would be there is no connection between two pages in that file, because you cannot properly connect the users, you cannot properly connect the posts, the comments and the likes, which are an integral part of a social media platform. In this case, you are considering Instagram, but you can consider any of the social media apps which are out there. The fourth and the final problem can be data corruption. If, let's say, two people are editing the same data simultaneously, things can break. And this is exactly why databases are necessary. I'll just type it out real quick and done. So the next thing which we'll be covering, which is the next section of this video, which is what is a relational database. Well, this video is around relational databases, and this exact series is around relational databases, so this is an integral part of this course. So this is the most important concept basically inside this course. So relational database basically store data in the form of tables, which is very similar to an Excel sheet. For example, we can have a users table. I'll just draw that out real quick. Let's take this part of the screen now. So let's say you are storing a user ID, a name, and let's say you are also storing age of the person. So let's say age. Now let's say user ID is 1 and name is ABCD, and ABCD is, let's say, 22 years old. User ID 2, let's say EFGH, and this is 23 years old. So this is in the format of an Excel sheet, or this is basically how we denote a table, very obvious thing. And there would be another thing, let's call it orders table. For that we'll have to name this something as well. Let's call this as the users and orders. So orders table would have order ID, user ID, and product name. So let's say the user ID in this order ID in this case is 101 and 102. User ID, let's say this is ordered by ABCD and this is ordered by ESGH. Product is, let's say, laptop, and let's say watch. So in this tables, what we have done, this specific row and this specific row can be interconnected with each other, right? If I'm saying, let's add another product into this. Let's say 103 is ordered by 1 again, and this is let's say a phone. So we can simply correlate that this user ID would be equal to this user ID if they exist in the same database, right? So this is the overall concept of a relational database system, and this is how it basically looks and works. There's nothing more I could say on this. So did you notice something important? The order ID table contains the user ID, and the user ID exists here as well, and they both can be interconnected. That's the summary of this section. The next section of this video would be, what is a relational database management system? I'll have to scroll a little bit downwards and good to go. So what is RDBMS, you may ask? I'll just write it out real quick. RDBMS. R is relational, DB is database, M is management, pardon my handwriting, it's always been bad, that's why I prefer typing, but anyways, S is for system. So this is the concept of RDBMS, relational database management system. A relational database is the concept, and an RDBMS is the actual software that manages it. Some example of RDBMS is MySQL. Another example is PostgreSQL. Another example is Oracle database. And another example was BSQL Lite. I think that's how they spell it. Instead of double L's, they use a single L. And yeah, so these are some examples of RDBMS, and these basically help the developers to store data, to update the data, to secure the data, and retrieve the data efficiently. So now the most obvious question in your head can be, why relational databases became so popular? So there's a huge reason behind that. There are many reasons behind that. I would say it provides you a structure. It structures your data, right? Structured data, it is helping in making relationships with each other. For example, one customer can have many orders, one student can have many subjects, one database can have many tables which are correlated to each other. Next point is the most important point, which is data consistency. What do I mean by that? So data consistency, this is extremely important. Imagine transferring money from one bank account to another, and you cannot afford to have money deducted from one account but not being added to the other account. Relational databases basically prevent this problem by using transactions. What are transactions, you may ask? We'll be covering that in one of the future videos. So yeah, that's the concept of why relational databases became popular. The next thing which we need to learn is asset properties. I'll scroll down a bit. I'll write it like this, and these are the properties of databases, of relational databases, I would say. So A is atomicity, C is consistency, I, can you guess what I is for? I is for isolation, and D is for durability. Durability, however you pronounce it. So what do each of them mean? So atomicity basically means that the entire operation either happens or it doesn't. It doesn't stop midway, like we discussed with the example of transferring money to a bank account. Either the transaction would entirely happen or it would not happen at all. The next point, consistency, it means that the database always remains valid. That means the data is consistent. It is, you get the point, right? Consistency. Isolation means that multiple users can work simultaneously and also safely without data being corrupt. And durability is, once your data is saved, it stays saved. It does not get deleted under any circumstances unless you delete it yourself. So these are the 4 pillars of relational database management systems: atomicity, consistency, isolation, and durability. I think I didn't go around consistency really well, so I'll explain it again just in case anyone is being confused. The database always remains valid. It means you can store data inside it, you can fetch data from there, you can delete data from there, you can read data from there, whatever the 4 CRUD operations, whatever we do: create, read, update, delete. So that is what facilitates this point of consistency. The next section which we'll be talking about is benefits of RDBMS. So let's summarize the benefits really quickly. The first benefit is high data integrity. I'll type it out while speaking. So high data integrity, it reduces data duplication, it provides you with powerful queries. I think queries. So yeah, that's 3 of them. There's one more benefit, and I want you to guess that in the comments. I'll explain these by the time you do. So high data integrity, which means data remains accurate unless and until you change it yourself. Reduced duplication means same information does not need to be repeated everywhere. Powerful queries means you can ask complex questions using SQL, like highest salary employee in a company, total sales this month, top scoring student in a school or in a class, whatever you like. And now comes the most important benefit of using RDBMS, which is security. So you can basically control who can view the data, edit the data, or delete the data, and it's totally up to you who decides all this. Now we are talking about the plus points of this. So also let's talk about the minus points of using an RDBMS instead of a NoSQL databases. So there are some limitations. I would not say there are many. So the first limitation, as I feel, is a rigid structure, which is also a benefit if you consider it in the right way. Another minus point is harder scaling. And it's not ideal for flexible data. Well, these are some of the limitations of using RDBMS. Rigid structure means you usually need predefined tables and schemas. You cannot define it from outside. Harder scaling means when applications become extremely massive, scaling a relational database can become difficult. Not ideal for flexible data means that things like chats or social feeds, which basically run on JSON files, they can become very hard to manage efficiently.
I'm sorry, I did not.
Oh, okay. Google Assistant got activated for some reason. Okay, now comes the next part of the video, which is what is a NoSQL database? SQL or SQL, however you like to call it. Got it. Okay, so NoSQL, I'll write it here. NoSQL. So NoSQL means not only SQL. It does not mean that completely denying SQL. These databases are basically designed for flexible and massive scale. Some examples are MongoDB, Redis, and Firebase. So yeah, these are some of the examples of NoSQL databases. Now comes the most interesting part of this video, which is comparing these two types of databases, SQL versus NoSQL. I will just write it right here. So tables and flexible documents, that's what we are comparing here. So that would be our first point in this. How do I make a table? I'm confused. I'm not used this for a while, I would say. I'll just do this real quick, and another text box here. NoSQL, well, good to go, I guess. I mean, I'm not putting much effort into this. Actually, I should put some effort into this, but anyways, so SQL is tables. It contains tables. This contains documents, I would say. They are called documents in MongoDB. I'm not sure about other databases. So this is flexible docs, I would say, documents. These are fixed schema. These cannot be like, you have to put it in order on how you want. We'll see this point when we are making videos about syntax and stuff, which can be the next video. So this is dynamic schema. My bad, I forgot the spelling of schema. SCHEME. I think I should erase this before anyone sees this. Not a ruler. I don't need a ruler for now. Okay, Dynamic schema. What is it? As we discussed, we cannot do it. Has a rigid structure and it has a flexible structure. That's a considerable point I think I would see here. Where did I put it? Yeah, rigid structure, which means that we have to specify every other thing which we are putting. It does not automatically recognize what's being fed to it. Meanwhile, dynamic schema is quite opposite, I would say. Like, we cannot store chats here because chats can go from any number to any number of characters. Meanwhile, in dynamic schema we can store chats, and it can be very easy to store chats actually. Next point to discuss here is strong relationships. And this has fewer relationships. I would say relations, because relationships is too long to write by hand. Don't call me lazy. Strong consistency is another point which we can put here. And this is more scalable than SQL databases. The next good point to consider here is this is great for structured data. And this is great for flexible data. And that's how we end the comparison part. And I'm pretty sure that it's clear from what you see here. But when it comes to actually utilizing their potentials, we need to learn when to use what, which is the next part of this video. So we use SQL when accuracy is a matter, when relationships are taken into consideration, where consistency also matters. For example, let's say banking, hospital systems, and student portals. These are some of the great examples of where SQL can be used. NoSQL can be used in flexible matters, in cases where massive scaling matters, in cases where data structure changes frequently. That's where we use NoSQL databases, like chats or social media feeds, I would say. And another great example for this is analytics system. Like when we see on YouTube, we see analytics, or if you run a business, you need to check the analytics from time to time to analyze how your sales were, or how your profit has increased by what percent, or how many new customers did you get, or how many old customers were renewed. That kind of stuff is what you need to check. Then NoSQL databases is the thing for you. One of the most important things I like to address here is that most modern companies use both side by side, and SQL and NoSQL databases are not enemies to each other. They just solve different problems. They have expertise in different areas, and that's what makes them different. That's what makes them unique, and that's what makes them useful as well. So yeah, in this video we learned what databases are, what relational databases are, what RDBMS means, benefits and limitations of RDBMS in SQL versus NoSQL differences, and in the next video we'll be going with syntax. I would like to share that Notion file. Where is it? Okay, these three is what we have covered today. Next video would be around these four things. We'll discuss a little bit about DDL as well. So this is what we'll be covering in the next video. So yeah, because once you understand databases, you start to really understand how the digital world actually works. So yeah, that's it for today's video, and I hope to see you in the next one, because we are getting somewhere. We'll be eventually starting with data engineering. And also let me know if you need the notes, these ones or what I have typed here, these ones. It's almost the same thing, but yeah, if you need them, I'll be putting the roadmap in the channel, not channel description, video description, and let's see how many people actually join that. That's how I know how many people are attentively listening to this. So yeah, see you in the next one, and till then, goodbye.